Mhm. All right. Hello, hello. And today I'm gonna work on my programming language again. Kast. There we go. There's a couple things that I wanted to do. One of them is updating this website, but I don't know if I will do it first. I'm not sure how much time I'm gonna spend. It's gonna be a short stream, but yeah. One of them is the website, and another one is actually making a feature. So I guess I'm gonna work on the feature first and see if I can get it done quickly. Test. All right. It's been a while since I worked on this. How does this thing work again? We have Rust 181 installed here. Okay. I don't think it matters. Bot. Hello, hello. What do we do here? Just run. And by default, it gets me into the REPL. Std print hello, right? Yep. Why kast? What do you mean why kast? Why not? Why bot? Why not link cider? Because we are waiting for something to release the game. I decided when to release the demo. I don't know. Davey said that we need to wait. Until Davey says that we no longer need to wait. We are waiting, I guess. I don't know. I think the this weekend I will probably be busy on Saturday, so I guess Sunday. Maybe, I don't know. Is there like any other like things that I should think about when to release a demo? I don't think it matters, right? It's a demo. It's not the actual release. I don't think we should think about it too much, but yeah, I don't know. What about you? Is your Steam page approved already? Hmm. To basically scan whether there's trailer on the screen. Alright. I can disable the trailer. If that helps you to not be distracted too much. Alright. So the feature that I want to add to the language is the ownership, I guess. We're on the borrow checker like in Rust, but I'm not gonna implement the borrow checker fully. We're going to have it made in a runtime borrow checker for now, I think. But the most important thing is that we have the performance issue. We were solving the advent of code with this, and the performance issue is bad, right? And the reason for that is, can I have an example? Let's try an example. Let's try an example which is going to call the big list. Yeah, so what I want is to make a big list here, right? So we say something like use std Oh, I need to remember how to do things. Lists. I don't have... Do I have a loop at all? Loops. We have a 4. But what about a normal loop? Do I have that? Do I have a while? While true. Instead of print hello. Print hello. Just run examples, big list. Okay, actually, wait, hold on. I actually have the whiles. All right, nice. So what can I do? I can say let. Do I have the mute keyword? Let mute iteration. Wait, do I have a range? Range. No, I don't have range. So we're going to write this like before. 0, so like while I is less than, let's say 100, right? We say I plus equal 1. Do I have plus equal 1? Number literal type could not be inferred, so I need to make sure that this is a known type, int32. Just redeeming my first BRB. Okay, there we go. This works. Nice. Give me a moment. In a while.
It's been a while.
Oh, big early. Okay, so what I'm trying to do here is not to print hello. What I'm actually trying to do is to say that I have a list, right? The array that I'm going to make, a list of like integers, right? So I initially create an empty list, and then I say something like list is... Do we have something like list push AI, right? And then in the end we do dbga. There you go. So this makes me a list of 100 numbers. Can I make the Rust to be quiet? Cargo run help. Quiet. There's literally the option like that. That's not quiet, that's warnings. Can I make it ultra quiet? That's just cargo log messages, right? Cargo, don't show warnings. Press warnings from the cargo command. Impossible. I believe your OBS settings suck, but I don't know why the letters are blurry. Are they? You know, pro it? No. This font is smaller, but it's cleaner somehow. Twitch TV, Cookie Man. Fine. What are you talking about? Let me see here. Fine. What are you talking about? Let me see here. Fine. 1, 2, 3. Let me see here. 1, 2, 3. Well, I mean, I would assume that actually it is because I am my monitor is 2K, but the stream is 1080p only, so it is being scaled, which makes them blurry. So if I made my monitor actually match the stream resolution, it would not be blurry, I think. It's not the OBS settings. It's just because like when you scale, it becomes more blurry, I guess. It's not that bad, is it? What if I scale it up? Hmm. That was blurry and huge. Right. Okay, what I want here is to figure out the timings of this, right? There is currently quite some time that has been spent on like parsing the standard library, I think. So I want to measure only this time here. Can I say start is let's say something like time.now. How about that? Right, time.now, and then I also dbg time.now minus start. We will do something simple like that, right? We're just going to make it return the floating point number. Standard library. Let's have it somewhere around here. So time is is that how I do it? Time is now is a function native time now. And this is a function from unit into the float 64, for example. For now, it's good enough, maybe. And then I implement that in the interpreter. Time now, the type is argument is unit. Do we call it unit? Wait, do we not have unit? Oh, it's type shape, unit. Into, right? That's how we do it. Result is going to be a float 64. Text empty. That's the function. Name is type now. Function type doesn't matter. Argument doesn't matter. We return value float now, and then I say that now is std time instant now. Can I get the something elapsed? No, that's elapsed since the duration. So I need a duration, right? Not an instant for that, which means that I want to store the start in kast itself, right? So kast start elapsed as xf64, something like that. So like kast is kast. In kast I will have the so inside cache start std time instant start std time instant now cast cache start elapsed. Threaded ordered float. Yeah, I need ordered float. So I need this to be converted into, right? Okay, so let me just fix these warnings too. Or let me first do time now. Time now. Cargo run quiet, and then let's just fix the warnings too. Source cast. Or what do we have? This very complex type used. Unused. Cast to type. If it's not a type, then yeah, we ignore the error here, I guess, right? Variable does need to be mutable. Make same. This is something that I actually will need to do later. Anyway. The language should have keyword typal and tup. Why? Look at this guy. The game runs very smoothly on the old laptop. My laptop is not old, by the way. It runs smooth there, but it's not old. It's just doesn't have. It only has the integrated GPU. You have an old laptop? You should test the game there then, right? Although I don't think I updated the this Steam build yet. I can do that real quick. I don't use mute here for now. Just allow. Unreachable. And there's a complex type used. What is this? Comment lines. Is this actually a complex type? It's just an optional box to din function. You silence that one on the crate level. The very complex type used. You have a lot of complex types in your code for sure, yeah. Allow. Complex. Type complexity, is that the one? Alright, it's only in the test. By the way. Code is inactive due to CFG. Can I disable that? That's just a hint. Right, anyway. When you create a blue sky forecast, should I make a blue sky account for it? I don't know. It's not yet there. Make an account for it. Okay, anyway, so here's what I'm doing, right? Let me commit that. Fix warnings. No, not everything. Fix warnings. We have this test. Here we make a big list, a list of 100 integers, right? Let's debug also time now here. What if I do this? Time.now. That's not going to work properly, right? Because that's just a function. I need a pipe then. I don't want parentheses. Holy shit, 100 integers. Can the computer hold that? Hello, Agma? Yeah, so the computer can hold this, but as you can see by these numbers, the timing is, it takes me 2.6 seconds to generate a list of 100 integers, right? So why is that? Why is that? That's very slow, right? Well, I mean, first of all, we are in the debug mode, but I don't think it's going to matter much. Cast bad, yes, basically. We need to make it good again. Unless why? Because I'm cloning everything too much. So when I, yeah, see this line over here, right? I'm making a new list out of the previous list by adding a new element to it, which clones the list and then adds a number to it. So this has quadratic complexity currently. Because I don't have like proper mutation, I mean, so I have this kind of mutation, which is just overriding the variable and scope with a new value, right? But I cannot get a mutable reference to the existing list like we can do in Rust, right? So we need that. We need proper references. Basically, what I want is to introduce the concept of places or L values, like in C++, right? Is there other languages than like Rust and C++ that has the concept of the L value? I see, I don't see. It's fine. You don't need to see it. It's going to be all magical working behind at some point. My coworkers complain that I'm building the Framework too fast, so once have decided to postpone my MacBook to keep development slower. Alright. WGSL has it. Arguably the dude cleaner. Okay, maybe I should look at that then. WGSL. When do I look at this? WGSL mutation. They do it cleaner than Rust and then C++? C Sharp or Java? If I was to choose between those two, I would choose personally C Sharp. But actually neither. I mean, it depends what you choose them for. If you want to select language for earning money, then probably Java instead. For backend, Rust. Whatever you do, don't use the C++ design, is deeply busted. All right, hold on. I want to see what they do in the WGSL. You find let mute to be kind of messy. It acts both like let x and like at mute x for both functions and are kind of mixed. How do I look how they do it in WGSL? Mute. Mutable bindings. Variables. Tour of GLSL. Error. WGPU is not supported by this browser. A variable represents a value stored in memory. The variables are declared with the var keyword. Variables are the only mutable objects in WGSL program. Immutable values are declared with the const override and let keyword. Var function. What do you mean var function? There's a mutable variable in the function address scope. Oh, you like specify the scope of it. Ah. Okay. Private workgroup uniform. Okay, and this kind of makes sense to me. But what about the actual like L value stuff? Expressions maybe. It's kind of like in Rust. There's only the spec. The language is quite young. Okay, so do I read the spec? WGSL spec. Is this the one? Textual structure. Directives, types, type checking, plain types. Do they have, what do they call it even? Do they call it place? Rust called these things places. C++ called this L value. They do have L value here. Uniformity graph. They have L values in uniformity graph. The only where I can find it. Memory views. Memory views, this thing, okay. Let's see. In addition to calculating with plain values, WGSL program also often read values from memory or write values to memory via memory access operations. Each memory access is performed by a memory view. A memory view comprises a set of memory locations in a particular address space. A memory model reference and interpretation of context of those locations as a WGSL type, known as the store type, and an access mode. The access mode of memory view must be supported by the address space. Hello, Athano. Storable types will contain the variable. Shareable. Is there any examples? Do you have the ref without special keyword, I guess? You have pointers, you have refs, right? Same as in Rust. The reference type identified with the set of memory views for memory locations as holding values of type T, supporting memory access is described by the mode AM. So access mode is like read, write, and read, write. Yeah, makes sense, makes sense. I will have something like that. So like, basically, I mean, yeah, eventually I want to have something similar to that. Although, like I was talking before about this, I want to split this into like access mode is like a separate thing. Address space. So address space function private uniform storage handle. I see. I don't have the alternative of that in the normal programming, right? This is just the shader stuff. If given the choice between C# and Java as the backend thing, I would choose Kast. Nice. But you will have to wait like 30 years before this language is ready. Yeah, I want to have write-only types too. I think that's useful. Okay, maybe not 30, maybe like 3. We'll see. It depends like how often I work on this, like, because, yeah. 35 before 0.1. 2 pointers. So like pointer type. In AS, holding values of type T, supporting memory accesses described by the mode AM. Wait, hold on. This and this is literally the same description. Here T is the store type. Here T is the store type. Pointer types may appear in WGSL source. Reference types are not written in WGSL source. Instead, they are used to analyze WGSL module. Okay, I see. So pointer, so like what we have in Rust is a pointer in terms of WGSL, not a reference, right? And a reference is probably something like the like an actual L value then? Is that so? I don't know. I don't really want to read the entire spec here. I was just like wondering what they're doing here. Valid and valid originating variable. The originating variable for a reference value R is defined as follows: is the variable, then R is a variable. So they have not. So instead of the lifetimes, they have the originating variable. Is that what this is about? Do they have borrow checking in WGSL? They don't need borrow checker because shaders are like that. A returning for a function from a pointer is not allowed. Yeah, makes sense. I guess. So we have like this reference. Pointer function I32. They don't specify the read-write mode here. Is that automatically inferred here? It wasn't this pointer having 3 generic arguments? The like memory scope, the type, and then the access mode? Where's the access mode? So what do you mean then they are doing it cleaner? How is it much difference than Rust? So like just like in Rust, you get a reference, right? And I guess in this case you get the read write. Even so, you don't specify at mute. You just get the pointer to it, and you still can read write it because it's just like inferred to have the read and write access to it. Is that the difference? Infers the pointer as the read write? Yeah. Have I seen Slang, Shader Lang? Oh, Raymarch. Slang. Does Slang has the is Slang the one by SDL3? Or is that the other one? Slang. Or SDL3 has its own thing. I don't remember. Do they have borrow checking? Well, I mean, I guess for the shaders, you just don't need it, right? Language specification and just point me to the GitHub. Amazing. So how do I read this? How do I read the thing? Okay, visibility, utils, types, subtyping, preprocessor, modules, lexical interface, generics, declarations, capabilities, autodiff. Lang versus WGSL. Is there no comparison between the two? Hello, Nigel. Hello, Olivia. And it's all in the Rust immutable binding kind of thing. They should have gotten rid of it. So what, like everything should be mutable by default? Is that what you want? Because, I mean, should you just be able to mutate anything? Just add mute, but it's different. It's a different thing, right? Because one of them is so like add mute x is basically a pointer that allows you to mutate the let's like is consider this at one point. They have the it in the blog post. All right. Will I get to some programming today? I don't know. Small baby steps, small cult. Is it here? Research stream. Well, I mean, yeah, it's an important topic. I already have some things that I want to do differently than Rust, but can I search here? See all posts. Both let x and let mute x represent memory. It's not like x is a value without a memory location. Intermutability requires that. Yes. Yes. But it's not the same as at mute x, right? If you want the memory to be mutable. Compiler always knows when a mute is missing in front of a binding, so it might just infer that. But sometimes you want to guarantee, like, I'm not sure if I agree, because it's like the same as it's like giving the contract so that you don't mutate it on accident, you know? Yeah, how do the devs know? Admin is carrying the weight, not mute X. I don't know. Let's if I have let x be 0 and then I say x plus equal 1, should this compile or not, Raymarch? What do you think? Should this compile without me? Or like, how do you see this being done differently? Like, we need to specify somewhere that this is immutable, right? So this should compile, that's what you think? I think that's wrong. I think that's like you want to guarantee that things are not being mutable. if you want this to compile, then I would want to have something separate, like const x, right? Something like JavaScript is doing, where you have let and const then, right? Instead of let and let mute. So I wanted to have this distinction anyway. If you're looking for a variable that might be changing, you need to be able to pinpoint it. Yeah. Yeah, I don't know. I think I don't agree with you, Raymarch, unfortunately. You can try to give me more arguments for it. Just have a mute x and otherwise just x. No, I think that having the let keyword is important to figure out when the bindings first appears. Something like Go language does a colon equal then to introduce the new variable and assign it to a value at the same time instead of having a let keyword. I like having a let though, I think. Without it, it's a little weird, especially if we have x equals 0 and then x equals 0 again. What is happening? Is this a new variable that is shadowing the previous one, or is this the mutation that's happening? Equality and assignment should be separable. Yeah. Well, I mean, equality. Equality is a. I think I'm going to use the double equal there for it. I think it's a little different. I think you guys just described pinpointing which variables might change is already something Rust does not have. Because of the interior mutability. Yeah, interior mutability is like the back door in Rust. Yeah. Mutability, yes. Anyway. Model language should use Unicode as does not equal. I don't know. How do you... But then you need to have some tooling from the text editor that will allow you to write the thing, right? Anyway, the most important thing for me right now is the problems of performance. So I'm cloning the values a little bit too much. So when I say... so what I want to implement is the concept of places, right? So when we compile something like this, it actually should, like, I don't know, like read a value of the place A. So like A is basically like a pointer which points to the data, which is the list itself, right? So when we see A, we actually read the value out of that pointer, but we can also like get the reference to it, and we want to like get a mutable reference, something. Why do other things in Rust bubble up, like the lifetimes? If all I can infer from @mute is that it is exclusive, then just call it X. Just make it so much easier to explain functions like into inner. All right, I'm not sure what we're arguing again. I don't know if we can, if we're getting to something there. um, Mutable reference pointer, and that's what the name says, but that's not what it does. I mean, isn't that what it does? It's a pointer that gives you the mutation access. Although sometimes you can have mutation through interimmutability. Sure. Like C++ when they call something unique pointer and it's not unique at all. Is there like is there a concept which you would like to see instead? Is there some idea that you actually have, Raymarch? Because I don't know. I mean, naming is difficult for sure, but I think Rust does it. I don't think there is any like problem with the logic with the thing. Can you repeat? I was just asking if you have some like specific proposal that like how would you want it to be handled? Do you want to have interior mutability? Do you want to get rid of, like, what if Rust did not have interior mutability, right? I think we like it's something that you have to have. You like the word mutable, not thrown around in places where that is not what it is doing. It's difficult to teach lifetimes to people if mutable means exclusive. Mutable and exclusive is like the same thing, though. Kind of. Why is it not? You can, like, if you have mutability, then it means that no one else can write to it. So it's like kind of the same thing. Anyway, I'm going to make it different. I don't know if like you were here when I was talking about this last time, but basically, in Rust, what is the reference? What is, like, when you say x is at mute like 0, right? What is this actually? So this is a type. Let's say reference to an integer 32. I mean, a mutable reference, right? But a mutable reference is basically just like the pointer, which is a pointer to this thing. And then also, like we were foreseeing in the thing, in the WGSL, it's like the access mode, right? The access mode is like basically the write. So it's two things at the same time. This thing is like zero, like zero-sized compile time kind of thing. So the idea is to split these things into two separate entities in the language. So I wouldn't even have mutable pointers at all. I would just have pointers, and I would have access that passed around. And in order to read the pointer, you need to have access around, basically. This idea is called the ghost cell. Here's the paper about it. Separating permissions from data in Rust. Right? So, yeah. My idea is to try to do something like this on the language level. So, like, I plan to have the effect system, right? So access mode is something that is like being passed around in the form of the like effect, in the form of the context. So this means that the code like this, over here, I have a mutable x, and then I have a closure that's trying to print x, right? So in order to do this, we need to read the value of x, right? And then we want to mutate this value, which means that we need to have a write access to x, and then we want to print x again, which means that we want to have read access again, right? But this is a closure. So what is this closure actually capturing? And the idea is that this closure would only capture the pointer, but it will have the extra, like, invisible argument to here in the form of, like, the effect, the context, which will say, like, mutates x, right? So I only check that I can mutate x when I actually call the closure, kind of thing. If that makes any sense. So yeah, the brief, like, difference of my idea. So this code will not compile in Rust, but it is supposed to compile for me, like guards. The context system is like the algebraic effect system. Do I have another example? Function contexts. Like, one of the other things that I'm going to use this for is, like, for allocation. So if a function needs to allocate, then you will see it in the function description, in the function, like, signature, that it allocates. If a function can panic, it can panic. If a function can mutate something, that it will be written there. So that's the idea, right? Like, capability, objects, algebraic effects. I call it the context system, but yeah. Anyway, we are far from, like, having that implemented. I mean, not far. We have the context system, but we are far from having the like, the borrow checking. Right now, I only copy everything everywhere, which is why the performance is really bad. Okay, it has been an hour. Can I actually do some coding now? Dean has brought a specific version to make it more literal that you're using a trait as a dynamic object. What's that about? Rust disagreed when it wrote the Dean keyword. There's still 8 minutes more to waste before a full hour wasted. All right. I mean, we can talk about something else. I wanted to, like, actually update the website, so, like, I talk about these things in more detail, but I don't know if I have a lot of time today. Maybe, like today was supposed to be a short stream. Maybe I update the website instead of actually coding then, because I don't know how quickly am I going to implement the thing. Is it difficult? Like I said, I only want to have, like, runtime borrow checking for now. And then, like, have the compilation be a little different. So when we read the value, it would, like, automatically inject, like, the read value instructions, and the actual, like, referencing a variable is just returning me the L value, the place of a thing, not the actual value that's inside, until we actually need the value, right? That's the idea here. Have I looked into the data log ever? Data log, is that a programming language? Hold on, data log. Module language, this one? Bracket lang, data log? Is it working? Declarative programming language? No, I have not read that. Subset of Prolog. I never looked at Prolog either. This is an example. Powerful effect-oriented programming language. Nice. Is that a new one? Is that a recent one? So they have the I/O, and this is based on effects, right? Algebraic data types and pattern matching, purity and impurity. Precisely tracks the purity of every expression. Polymorphic effects. Yep. Nice. Nice. Region-based local mutation. Okay. Higher-kinded types. Okay, so this actually looks to me like a better version of the Coca language. Total funding 1 million euros. Okay. Make website in this format. Yeah, this looks kind of nice. Why did I not see this before? Is this a new one? How old is this? 3 days ago? Sponsors, JetBrains, IntelliJ IDEA. Wait, is this written in Java? Gradle? Huh? What? 10 years ago? So it looks like Scala is JVM? Yeah. I mean, all right. Why did we never see about this one, Nerdsoul? We claim that all of the upcoming effect-oriented programming language X offers the most complete language implementation, the most extensive standard library, the most detailed documentation, and the best tool support. It's just the best language. What? Should we stop making kast and like just go to Flix? There should be something wrong with this one, right? They're just the best. I mean, they say so, so why wouldn't we believe them? Extensible records, traits, everything that I was missing in Coca language, they literally have it all here, right? Associated types and effects, structured concurrency. Okay, what they don't have and we have is the extensible syntax, whether it's a plus or a positive or a negative for us. And also it's a language that is already working, I guess, unlike our language. Purity reflection. Flix supports a metaprogramming construct that enables higher order functions to inspect the purity of a function argument and use that information to vary the behavior. Does that work at compile time or does that work at runtime? When I can exploit purity reflection to selectively use lazy or parallel evaluation inside the library without changing the semantics from the point of view of the clients. We can inspect the purity of the function argument. Inspect. F is a function, A into B with some effects. Right? So this is the generic effect. Effect polymorphism is this, right? A reify F. So if it's a pure, then F is pure. If it's not, then it's not pure. But is this like happening at runtime? Compile time? We can use purity information to safely switch between lazy or parallel evaluation. In this case, if F is pure, then perform the map operation lazily. F is a function from A to B with effects. L is a lazy list of A. We return the lazy list of B with the same effects that the function had. All right. Reify. If it was pure, then we map L. Otherwise, we map E. The naming, I don't really like this naming. This feels like Haskell. The map M underscore namings. But L means lazy or parallel evaluation, I guess. It's a syntax. Map L is a syntax. I mean, yes, semantics is. I like what I'm seeing here. Yes. This is all looking nice. Do they have mutation then? All right, here's a question. Does this language has mutation? Or what do they have in this language? So, like, we want to be able to write code that is fast, right? If you was to use language like Haskell, you would need to write something really ugly if you want it to be fast. I mean, they should have some sort of mutation. Okay, do they have? Is this like garbage collected language? Where do I look at about this? Frequently asked questions. They support integration with Java, Kotlin, and Scala, huh? All right. Looks similar to Scala. This looks like an eval as an nascent. What does this word even mean? Nascent REPL. IDE support. VS Code plugin. File to LVM, no. And no plans. WASM, not yet. The support complete inference, yes. Variant of Hindle-Milner. The best way to start learning the SL. On-time performance runs on the JVM. Flix also features full tail call elimination, which has some runtime performance cost. Haskell and OCaml compile to native code, thus by definition they must be faster than Flix. That's not true, sure. What are the features not supported by Flix? All right, null, sure. Non-total functions. Wait, they don't support non-total functions, but they have effects, so they it's already like this library has been designated designed to avoid common programming mistakes. We want functions that are safe and have accurate type signatures. For example, in like Scala and Haskell, the head returns an option. Yeah, that's something that I really hate about the Haskell standard library. Sure. Silent coercions, no code before main. Equality and assignment. Undefined behavior is not there. All right, what about mutability? Is that really not in the frequently asked questions? Division by 0 is 0, really? Wait, what? What controversial choices are made in Flix? Dividing by 0 yields 0. All right. Trash language. Unused variables are compile time errors. Oof. Shadowed variables are compile time errors. Oof. Unused definitions type are compile time errors. Oof. No variadic or labeled function arguments. No warnings, only... Wait, what? No, they have absolutely no warnings? Only compile time errors? Alright. Control F mutable. Yeah, well, I'm just going to read through this. Where does the Flix name come from? We don't remember. Fix point. You don't seem to understand type theory, computers. Is that something that people tell them all often? Why is that in the frequently asked questions? Right. Will probably be in my frequently asked questions too. Why does the website require JavaScript? The page does not load. The site requires JavaScript. Spears actually great from a technical point of view, but less board is pointless. Ideas from Rust and Scala. How the fuck does anyone understand such weird syntax? I hate all the symbols. Doesn't matter. It's the worst syntax, doesn't matter. Alright. I don't see anything about mutability. Control F mute doesn't like... Okay, so this is like... So people don't care about the fact that Like mutability is not. Why is it not in the frequently asked questions? The sentence below the div by zero thing is the most offensive thing. I focusing. What do you mean? This one? Yes, but focusing on this is a bit like focusing on the color of the seats in a spacecraft. I don't know. Like you can you not answer any questions with this though? Like I don't know. Like any function can panic in Rust, but should we not focus on that because like it doesn't matter? It's like focusing on the color of the seats in the spacecraft. It's fine, right? JavaScript is okay. Don't focus on the things too much. On main page, region-based local mutation. Oh yeah, I heard about the region-based. We support region-based local mutation, which makes it possible to implement pure functions that internally uses mutable states and destructive operations as long as these operations are confined to the region. You can use local mutation when it is more natural to write a function using mutable data in a familiar imperative style while still remaining pure to the outside world. You can also use local mutation, which is more efficient to use mutable data structures. So you cannot pass a reference to a local thing, though. Like when you say local mutation, it's like region R, right? So like lifetime, region, whatever. You have this string builder inside this region, sure. But can you pass this string builder that is tied to this region to a different function? You have the wait, first of all, they have the region as an argument. Okay, where is the documentation? Mutable data. Flix is a functional first programming language that encourages but does not demand the use of immutable data structures, while immutable data structures should be the default. Flix has rich support for embedded programming with destructive updates to immutable data. Use the effect system to separate pure and impure code. In particular, Flix uses the region concept to track the use of mutable memory. That is, all mutable memory belongs to some statically scoped region. So we have basic types of mutable memory references, arrays, and structs. Regions. For scope to mutable memory inflicts, all mutable memory belongs to a region that is tied to its lexical scope. When execution leaves the lexical scope of a region, all memory in that region becomes unreachable. Regions are useful. Sure. We introduce a new region with a region construct. Use regions to implement a pure sort function which internally uses mutation. List to array. All right, sure. And then you sort it. So does it mean that lists are something that is not tied to a region and arrays are something that is tied to a region? Seems like there is double copying happening here. But maybe not, I don't know. Introducing a region named RC, we use the function to array to convert the list to an immutable array associated with the region RC. We then sort array using array sort, which uses an efficient in-place sorting algorithm. So my question is how to implement this. Where's the definition of the sort, actually? Another example, we can implement a toString function for list A, which is pure, but internally uses mutable string builder. List for each x string builder upon string. Append this to SB. L. It's weird that the append string says takes the thing that we are appending to as a second argument and the thing that we are appending to this as a first argument. It seems like the arguments are reversed here, but let's not focus on that. It's like seating the spacecraft. The programming pattern is the same. We open a new region, allocate a string builder in the region, fill the builder with strings and convert it into one string. OCaml does something like that. Yeah, I remember reading about the OCaml region stuff. But in OCaml you can like return in like from a function the stuff that is like tied to the region of the function that's calling the function something something. I remember reading about this a little bit, yeah. It's not quite as powerful as the Rust lifetimes though, I think. But it is simpler for sure. Regions are values. A region or region handle is a value that can be passed to a function argument. This is useful, for example, when we want to write a reusable function that allocates and returns a mutable data structure. So we have a region R. The function takes a handle RC, allocates a new mutable deck in the given region, inserts all elements to the list L in the deck, and returns it. Yeah. Like, that is kind of nice. But what does this mean? What is this R? Region R, list A. So they have also implicit generic arguments, is that right? Like in Haskell and stuff. So this is technically a generic thing with R and A being the generic arguments, right? So a region, and this is like so this R is basically like a lifetime in Rust, I guess. Is the backward slash a binary operator on the type level? This is showing the effects. I thought. Like, this is the IO. So, like, basically you have a function main, this returns unit, but has the IO effects. So, I use the with keyword instead of the backslash. Maybe, I mean, backslash is not that bad, actually. I might use this in our language. So, if you want the function that allocates, right? I use with, but this could be a backslash instead. I don't know, so that it's like typed shorter. I don't know, which is better, you think? You like with? Yeah, I don't know. I think with, I think like using in general the words instead of symbols is going to be more readable, even although it's like more verbose, I guess. I don't know. I don't care about verbosity too much, but yeah. Symbols better than words? I mean, if there is too many symbols, then it's like weird. Like, do you prefer d colon equal or let d equal? Because I think that let is like more readable to me than like searching for a colon in the assignments. You love APL? APL. That's the language that uses only symbols for everything, right? Okay, so we just return the thing. So the wait, hold on. So if this is an effect, then this means that the regions are also treated as effects. That's weird. What does that mean? The function takes a region handle RC, allocates a new mutable deck in the given region, inserts all elements of the list L in the deck, and returns it. Regions are scoped. Regions and all memory associated with them cannot outlive their lexical scope. Here we allocate array at RC. So this should not compile. Region variable RC escapes its scope. Sure. Supports mutable scoped references. A reference is a box whose value can change over time. The three key reference operations are creating a reference ref fresh. RC is a region. And E is what? In Flix, the type of reference is ref tr, where T is the type and R is the region. So it's like lifetime. I mean, yeah, the regions are like lifetimes. I've seen somewhere like a proposal where they like proposed in Rust to do instead of a lifetime a region too. Fresh RCE operation allocates a reference cell in a region of the heap and returns its location. So wait, so you can only have the reference on the heap. So only boxed references, right? You cannot actually get a reference to the thing. I disagree how programming languages use equals. You would want something like left or colon equal. I think I can see that. Yeah, I'm actually like considering that idea, Raymarch. I think one of the things about the syntax actually that's important, and like in all the decisions that like people are considering when doing the syntax, it matters a lot to do like whether like let's say the await keyword, right? In Rust it's postfix, and like in something like JavaScript it's prefix. But I kind of want, like, sometimes you want one and sometimes you want the other. And like if we use the arrow for assignment, then it means that we can do it the two ways. We can do like assign 0 to x, and we can say take 0 and assign it to x, because we will be able to do it both ways then. I think I like the ability to like be able to swap the arguments. That's why I like the pipe operators, you know, like function with argument x, or x pipe into the function x, right? Into x pipe into the function. There's also the type ascriptions, for example. If I say x of type int32, right? I also want to be able to say int32 of x. I already have this syntax currently, I think. And like similarly to that, other things, like whatever makes sense in the current program. For downward. Wait, 0. This one. Oh, like this one. X. Assign 0 to x. No, I think that one is a little bit too much. That's yeah. Allocating references, reference fresh. Okay, so reference is basically like the it's like the IO refs from Haskell is what I'm seeing here, maybe. They don't say that the reference is mutating or not mutating. As long as you have references, you can mutate it, I would assume, right? Yeah, you can, yeah, reference put, reference get. This is literally the IORef from Haskell. Or like the ref cell, I guess, or just cell from Rust, maybe. So you don't have proper references here. When the stream is over, I will have lost all my credibility. Mutable tuples and records. Fixed tuples and records are immutable. However, tuples and records may contain mutable references. Okay, so they have like, yeah, this is just a way of internal mutability, basically. Yeah. All right, I'm not really like too big of a fan of this, but that's how they do it in like OCaml too. Does mutating a reference actually has the effect though? It should have the effect, and I guess the effect is the region, right? So when you say like reference get, I mean maybe you don't even need it because you're inside the region anyway, right? I don't know. I feel like this is not better than in Rust. This is worse than in Rust. Not sure. Programming with effects requires a new mindset, an effect-oriented mindset. I feel like this is not true. I feel like effects are really easy and understandable, and anyone can understand that. It's not like a monad. Let's see how this looks here. Non-deterministic, IO, run with handler, secret, get secret, guess. Yeah, this looks nice. Yes. So the only problem with this language so far that I'm seeing is the way they are doing mutability. Laziness. I also have laziness. Lazy. Lazy keyword. And then force. Right. What about the type of this? It's just, it makes the type lazy, right? I feel like this this should just be a library feature in that case. Purity reflection. Purity reflection enables higher order functions to respect the purity of the function arguments. Wait, hold on, but what is the purity? Are all the effects that you have, is all of the effects pure? I mean, is any effect making the function impure? Because I think that's too limiting. I feel like there are some effects that can still be parallelized. Like some effects you cannot, but some effects you can. It's not just about being pure, I would think. It's a sentence you can refer to if someone points a flaw in your language. You just require a different mindset. Humans and vampires. Enum person underscore is alive. A person who is born is alive. True. A person who is alive and is bitten becomes a vampire. Okay, so they have they can have like this is basically like const generics, right? Okay. Type level. Wait, hold on. Type level booleans. Is it only booleans? A unique Flix feature is support for type level boolean formulas. So it's not const generic. It's a boolean generic. Why is it limited to booleans only? You can use type level boolean formulas to statically enforce program invariants. While type-level Boolean formulas are not as expressive as general refinement types or dependent types, they support complete type inference and parametric polymorphism. It's just because it's easier to implement, once again, I think, for this language. They don't have dependent types. Bad. Anonymous and named holes. Through development. Oh, okay, I see. That's a different thing that I expected it to be. Okay, I mean it's not a bad language. I think it's not a bad language, but it doesn't mean that that it's better than kast. So we can continue working on our language still. It just makes it decidable, yeah. What's the term for the thing insects have, like the outside skeleton? Oh, Devnin, yeah. A cast stream? Yes, a cast stream. Although it has been 1.5 hours, we did nothing. And I don't have a lot of time today. I was going to like to try and implement the L value place stuff, but how will I fix Rust's ORD partial ORD problems? What's the problem though? What is the problem that needs fixing? Smile a lot. That's the best string material. All right, sure. Wasn't there a thing that ORD implies partial ORD and for F32 that messed up or something? Um. 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 I mean, right now I'm using the ordered float specifically, so I'm not. I don't have partial ORD. I only have ORD currently. Would we have partial ORD to be able to have the like? Is this true? No, that is not true. That is not true. Okay, let's see if I can like think about the plan in the next 15 minutes, then we will go ahead with implementation. If not, then maybe I will do something else. Maybe we'll read some more stuff, about something. So here is my intermediate representation, right? And like I said, we need to have a specific instruction. So right now, here we go, right? The binding. We have this instruction that's called binding. This is me getting the like the value of the binding. And what happens right now when I am evaluating this, right? I'm finding this and I'm cloning the value, right? I'm cloning the value of the binding. But what it actually should do, it should return only the basically the reference to the value. And if I actually want to get the value, then there is going to be an extra instruction in the intermediate representation, which is like get the value out of a reference, right? Play Neil fun. Nah, let's do something productive. Maybe. So yeah, the this means that I should have another type of a value, right? So the these are all the values that we have in the language currently. And what I should have is the reference or a pointer, whatever, like but yeah, basically a reference is what I need. So reference. What is a reference? A reference is a reference to a place. I think we should call this place. Yes. So there we go. We introduced the concept of places, right? So we have values. Values, they live in places. And in order to reference to a place, we construct a reference, right? So we have values, places where the values live, and references that point to the places. That's how it works in Rust 2, I'm pretty sure. So we have a place. What is a place? So since for now I will want to be able to construct multiple references to the same place, a place is basically like a ref cell, maybe like reference counted ref cell, right? So data is a reference counted ref cell which contains a value inside. And maybe also since I will be able to move the values out of the places, right? So we have the move semantics. This will be a ref cell of optional values. So if the value is uninitialized for now, inside the interpreter, we will just have none there, right? If we move the value out of the place, then the place has no value again, right? So that's what it means, kind of. We can also have it instead of an option. We can have place state, and we can have place state is one of the three things, so that we like actually make a distinction. If it is uninitialized placed, if it is like is Spark my own construct? Yeah, Park is like the arc, but it changes the hash and equality operators for so like it's hashing the pointer instead of hashing the contents behind the arc. And null reference. No, it's not a null reference. It's more like this is only like the implementation detail of the interpreter. It's supposed to then eventually be like it's supposed to be like checked at compile time with the borrow checker and like other checks that we're not using uninitialized values, right? But for the sake of the interpreter, we should have that. uninitialized. What do I call initialized? And then like moved out, right? So we start with an uninitialized place, then we have the value there. Do I just call it value? And then we potentially move out of the value, right? So those are the three states of the place. So the reason for this is so that I report different error messages based on like what is the error. Did I try to use an initialized value, or did I try to use the value after it has been moved out, right? Editor, all of them. Yeah, we use NeoVim currently. Hello, Elev. But sometimes we use other ref cell. Wait, do I not use ref cells in this project yet? This is the first ref cell. No way. Oh, because I'm using mutex probably, right? Yeah, because these are I need mutex. Sure. Neovite. I'm not using Neovite currently. They have a bug with the ligatures currently, so I could downgrade, or I'm just using NeoVim in terminal currently. Do I know Z? Yeah, I know Z. I also wanted to try Z, but I mean, but I don't know. I just don't feel like spending a lot of time migrating to a different editor. No editor talk. He's currently casting. Yeah, I just don't want to be distracted too much. But yeah, I think I will eventually move to Z. Place. So place should be clonable. Because place is basically itself just a reference to a place, right? Which means that maybe this should be a place ref, and this should be a place, right? So the place itself is like this, and this is the place reference. So reference is always a reference to a place. There you go. Which we can just call a reference, maybe. I don't know. Anyway, derive, clone, hash, partial egg. Is that what I want? You just found me on Twitch and you start to love my stream? Nice, nice. So we're making a programming language here. It's supposed to be the programming language that is, like, you know, the best one. Just like that other language that we just looked into. They call them themselves the best language, but did they call themselves the best language? No, it's just like the most complete language, the most extensive standard library, the most detailed, and the best tool support. I see. Out of the upcoming effect-oriented programming languages, of course. Not out of all languages. All right. So the best, but out of the like new languages, basically. I see. Okay, so now that I have introduced the references as the things, right? Where do I not compile? Over here. So we have inference for values. If I have a reference, then they must be the same references, I think, for now. So if it's a reference A and a reference B, then they must be the same. If A is equal to B, then how do I do this? value shape, reference A, just like that. And then if we have a reference and anything else, then the inference is failing. Okay. What else? Display. So if I want to display a reference, then I say fmtf like this. So we just implement the display for the reference itself. Implement std fmt display for place ref. What do I show when I display this thing? Maybe just the ID, I guess. So we should have the places to have the IDs, right? Okay, sure. We have a place. So then this is after all the place state. Then I have the struct place, which contains ID, which is basically like an address in memory. For example, if we're compiling to native, right? And then state is a mutex place state, like that, I guess. So then I just say write f reference to self the self place ID. I will rename this to be place, right? Okay, the type. Okay, the type. So if I have a reference, then what is the type of a reference? The type of a reference. So we need to introduce not only the values that are referenced, but also the reference type. The reference type that is referencing the type of the thing, right? So reference dot place type clone. So inside a place, we also should store then the type of the value that we're storing inside there. Type. Is that right? What did you also had place state moved back in so that I can move this stuff back into it? I think if we move back in, then it goes back to the normal state, which is, I don't know, what should I call the normal state, which is just like this. I think we move out. If we move back in, then we go back to this state, right? Which contains a value. Okay, these are all of my types, and now we have a new type which is called ref. The reference type contains the reference to another type inside, like that. Show short type shape ref. Just some is another option, I guess. What about something like if in Rust? I don't know. We can call it also init, right? Because it's like maybe uninit, and then we like it's like uninit or init, right? Assume init. It's like it's just initialized place. Hmm. Substitute bindings. Type shape reference to the reference type. Then type shape reference. Type substitute bindings cache. For the type inference, if I see the reference A and I see the reference B, then it means that both of the types that we're referring to should be the same types, right? So we say self ref inferable make same A and B. If it's a reference and a not reference, then the inference should fail. Question mark is here. If I have a reference type to this, then I want to write this type as a reference to the type, just like that, I guess. That's how we show a reference type. Maybe. This one. This is a type of a value. So if I have... Oh, I just needed the into here. I see. It's fine. Infer value shape. Type shape reference. I guess we don't infer any value for it. Or none. Okay. Okay, so you say we should call it just. Who's the best with naming things, actually? Isn't Raymarch the best one? Are you still here? What should I call the place that is initialized? I don't know. Sure, let's call it just. I don't care too much what it's called. Occupied? Oh shit, occupied. Yeah, okay, hold on. It's occupied. Like the like in the entry API, right? Of the maps. Like occupied. There's occupied and there is like vacant entries, right? It's kind of similar. Although we don't have it vacant. It's if it's vacant, then it's either uninitialized or moved out, basically. Taken. No, I think taken is wrong. Taken is more like moved out. I feel like. Initialized. I feel I like the occupied so far the best. This place is taken. I feel like the place is occupied makes more sense than taken. Taken is like reserved or something, isn't that right? But it's not reserved. Like somebody actually is occupying the place currently, right? I feel like occupied is the best one. This place is taken. Yeah, we can edit this as a comment, sure. Occupied is the best, please proceed. You don't want you don't want me to spend an hour figuring out the name for this? Okay, now that I have this, how are we storing the actual things inside the interpreter, right? So interpreter has this thing that has so I can get by a symbol a value, right? But now the API should be different. When I get the thing by a symbol, it should give me the place, the reference to the place, and not the value. And I only should like get the value out of it with like an explicit operation, right? So I guess the lookup inside scopes, right? Yeah, this is scopes. Inside scopes we have locals, and over here we store basically an ID. So this is basically like a map from the name of a variable to the actual value of the variable, but now we store not the values directly, but places, parked places, right? So we can like share them. Please make this public. Okay, so yeah, now we store for every variable a place, which might contain a value and might not, right? So when I insert a value, this is basically assigning value to the symbol. I actually like make a new place. When am I using this? Let's see. So I say insert into the scope, compiler scope, and interpreter scope. So, for example, I insert into the scopes when interpreting, when I'm doing pattern matching, right? Yes. This pattern matching, this pattern matching. And this also is pattern. Yeah, so like basically when I'm doing pattern matching, which is happening in the let expressions too, in the compiler, and also there is this inject binding. Okay. Sure. What about the compiler scope? Okay, I think this is fine. So I think we can still have this API to be the same. So I basically insert by the name of the thing, the value. Inside the scope, I still have the same stuff. So in the locals, we still insert a value, but over here I construct a new place, right? So place where, so we construct a new place basically, right? New ID. Type is value type. Value. This is not value, this is state. Place state. So it is initially occupied with the value. Like that. Okay, so when I look up by the name, I don't get the value back, but I instead get the reference to a place here, right? Well, I mean, so basically these symbols are like just place ref, right? That's what I call here, place ref. Yeah, place ref. Sure. I mean, it doesn't matter. It's the same thing. What happened? We smashed and closed the limiter. Like that. So when I'm looking things up, I get this symbol and the reference to the place, just like before, right? So that compiles. Then if I get the mutable, I guess get mutable doesn't really make sense anymore, right? Because I basically have internal mutability now, since this has the reference and the actual date is behind the mutex. So I don't need this at all. So for example here, function look up. What is this? This is scope look up. So when I look up, I apply a function there. Okay. I think this can just return now. Directly. Optional symbol and place ref. So if let some result be this dot I get lookup. And we return some result, but in this case result is like a reference, but I should just be able to clone it here because this is just cloning the reference, right? What is my symbol? Symbol is this. This is not super cheap to clone. This could be an arcster. Instead, then into, sure. Okay, let's see other things that don't compile now. You've never used the star editor, but sure, VS Code better than star. So yeah, if some what is this? This is look up. We just say some result, result like that. Let me looking up in the parent scope. Look up R. Yeah, R, we don't no longer have this thing. Yeah, yeah. Get cloned. So previously I needed to get cloned, and now I no longer like this is literally can be deleted. Whatever if I need to clone something, I just get it from there directly. So compiler scope, when I look up and I want to get an actual value, do I get the actual value here though? What am I doing here? So when I'm compiling my code and I see a simple token, which is an identifier, then I'm trying to get the value. So I'm trying to look it up with the hygiene. When I compile, and I see this. Maybe in the compiler scope we're gonna get the value directly. So this means that instead of get cloned, we say that I'm doing the lookup. I have the symbol and the value, and then I need to have the value dot. So the value is the place reference, right? Value dot clone value. Let's have a method like that on a place reference function clone value. Should this return an option? And then I should like okay, I will just unwrap here. Now let's say expect well, I think we can just return a result. On value should return a result. Result value and place error. Place error. So it's either we cannot do it because it's uninitialized or because it's moved out. Like one of the two errors. Derive this error. Debug. Place is uninitialized. Place has been moved out. Is that how you say it? So I just say self place state block unwrap get clone for place state function get going to return the result reference to the value and place error self uninitialized place error uninitialized out moved out okay value this is in the interpreter scope. In the interpreter scope, I should not be cloning the value directly, and when I say the get, this should return me the place reference for sure. Maybe I will do the same in compiler too. We'll see. So I just do lookup. And that's it. Next, no method inferred. So now over here, right? What is this even? Hold on. This is substituting the bindings. If I have a binding, then I should actually get the value here. So this value is the place. Substituting bindings, all right. Value, clone value. Unwrap. I guess here cloning the value is fine. Mutate symbol value. So mutate was just replacing the value, right? But now, since I have it as the same place, I can just like have it as a method on the place directly. I don't need that. This is evaluation of a binding. So when I evaluate the binding, this returns a place ref, but I should have a value, right? Which means that the result of a binding expression is value is a reference, right? Like that. Okay. If I have a recursive thing, the tuple fields is inferred to be references, but we actually want that. I see. How you should make a programming language? What do you mean by that? How can I, or how, like, or why should I, or like, or how do you make a programming language? What's the actual question? We make it because we can, because it's fun. Why we make it? That's the answer to the why, right? Because it's fun. How? I don't know. I know nothing about making languages. I'm just doing it, figuring it out on the way. The type of fields is inferred to be the tuple of references. Yes, because the values here. Yes. So it should be a tuple of values. Boom, ba-da-dum, bum. How can you make a programming language from scratch? I mean, I don't know. You start from scratch and then you like build more things into it. Well, I started by making a syntax parsing. Then we made an interpreter. Then I did some typing. So we have we have the concept of a compiler, although I'm not compiling to native code. I'm compiling to like my own intermediate presentation with like type information and stuff, which I am then interpreting currently. But also, like, trying out a bunch of different programming languages helps, I guess. Looking at what other programming languages do. I don't really like look at how they implement things, but it helps me to understand what I want out of a programming language. So I kind of have an idea of what I want to make. But it's difficult, for sure. So here's the thing, right? So I have tuples. And I should be able to have a reference to a field of a tuple, right? Which means that tuples should actually contain not values inside, but other references, right? Because that's the only way for me to construct a reference to it. Everything should be behind a reference, right? So this should be a tuple of place references. That's right. Not even a try hash then, just a hash. So if I have a tuple, then the type of a tuple, so the field in this case is not a value, this is a reference to a value basically, right? But I have the field place, and the field place has the type associated with it, which I should clone out of there then. Expect tuple. So tuple is a tuple of places now. All right, that complicates things, but sure. When I infer the things, wait a second. So if I infer things in my so like for inference, I should actually get the values there, right? Okay, so A is a place and B is a place. Okay, how do I construct a thing, a new place containing a value? I did it somewhere. Mutex, new this thing. So this is place ref new. So new value something something. So this is constructing a new place and gives me the reference to that place, basically. That's what I want to be able to do, right? Function new value. Like this. So if I have a tuple, and I know that two tuples must be the same thing, because we won't have inference for values basically in this language. So we get the values. Also, sometimes I don't really need to clone the value, right? But I can take the value out. So I have clone value, but I also should be able to like take value, right? Take value, result, value, place error. So this is the same thing, but instead of get, I say take on a place state. So this take takes a mutable reference to the place state, gives me the owned value, and if I am uninitialized, then it is uninitialized. If it is moved out, then it is moved out. But if it is occupied, if it is occupied, then the then I should return the value. Right? But I also should say before that self is place state moved out. So this is when I'm actually moving the things out, taking the value out of a place. But this is a reference, so I need to over here. So I cannot really do this, right? Can I? Because we move the thing and it doesn't implement the copy trait. Yeah. So this means that I should first check if it's occupied, and then I should say standard memory replace. So I'm replacing self with the moved out, right? And then this value, let place state occupied value be this, or unreachable, I guess. And then we return this value. Okay. So over here, when I'm doing the inference, I can actually just take the values here, I think. I'm not sure. But I think that's, yeah, I think that's fine. Because I'm owning both values already, right? Yeah. Should be fine. That's just like an optimization, kind of. So value is now a value. And I construct out of those values a new place, right? So I do a new place reference with this value, right? Right. Okay, next, infer value shape. So if I have a tuple, then value new not inferred of type dot map place ref a new value. I guess that's what I do. No method expect type for a hash map. Key is a place reference because arguments is a value, because arguments is a tuple. And I need to take the values out of there, right? Yeah, so over here I can also take the values out of it because I'm owning the value, right? So we expect tuple and then I map the tuple. Value take the value, but this can take the result. I cannot do a question mark here. I'm pretty sure I can just unwrap here though. Is there a thing that is called try map in Rust? Hold on, Rust try map. No? I mean, that's something that I should implement myself because it's a tuple. Yeah. Okay, I just unwrap. Pretty sure it's fine here. Down, 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 So now I should do this everywhere. Yeah, now I should do it everywhere. Map value take value map. Should I have a method like that? Expect tuple is a thing that gives me a tuple of place refs. Can I have an implementation on tuple of place refs? Function take values, since I'm owning them, right? Should be a tuple of values. Self map give value take value. I mean, that's not a value, like that's like a place. Cannot define the inherent impl for the outside type. Yeah, whatever. I don't do it then. Place take value wrap. Yeah, now I need to do that everywhere. Why is my tuple not in my crate? It's in a different. It's in my crate, but I'm splitting my stuff in multiple crates, right? It's in the utility tray crate currently. Key is a value, but this tuple is supposed to have values place ref. You know what I should do actually? Maybe. So I have a value shaped tuple. This contains a tuple underneath, but I feel like I should have a tuple value and my own like struct here. That will help for sure. Struct tuple value. So tuple value is a thing that inside contains a tuple of place references, right? But then the equality is not doing the same that as I wanted it to do anymore, actually, now that I'm thinking about it. Because this was supposed to be the thing that is owning the things, right? But the only reason I'm doing the references here is because I want to be able in code to take a reference to a tuple field. And it shouldn't be like a Rust reference, it should be like a value reference, which is like that. Yeah, otherwise I will have the lifetime issues. It's fine. I feel like for tuple values, I will just have function like get. I don't know, into values. It's a tuple of actual values, right? So self 0 map place take value wrap. That's what I want. So tuple over here, the type of a tuple so into values and function I think I just make it to be derived, impl deref. Derive deref. Do I have that? No. Okay, fine. Impl standard deref for tuple value. Type target is tuple place references. Self 0. That should do it. Expect tuple. So this should return me a tuple value. Didn't make it from scratch. What did I make it from? I made it from Rust. Is that right? Imagine making a language in Scratch. Mesh types. What is this? Inference for values. Okay. So over here, I just do into values for A and into values for B. Then I make them same. And then the result is a tuple of place refs. I think we just like do values and then over here I say result into. And I have for a tuple value something like impl from tuple values for tuple value. So this would be self values map value map place ref new value. All right. WTF? Where? This thing? All right. You just need to learn a little bit of Rust. It's not that you just need to understand Velik. It all makes perfect sense here, my code, right? Okay, what do we have here? Cast call. We have a value tuple. Expected value found place ref. So handler is a place ref. What is a oh shit? What is a handler? Expects tuple. Tuple with handle. What? Okay, sure. Into values. Oh shit. Sure. And then over here, I have a tuple of actual values, and I want to, yeah, just do into here. Into, clone, clone, clone. That's how we write code here, I guess. Key values, map values. Why am I cloning these things here? Anyway, doesn't matter. So this is a function that says contains. So arguments is this into values. Yeah, that's what I need here. This is another native function. Expect list. I guess lists also should wait. Hold on. Since I want to be able to construct references to elements inside a list, this means that the list should also contain the references inside. I'll change that later, I guess. Expected value found place ref handler. Expect tuple into values. This thing expect tuple into values. Set native. Expect tuple into values. Expect tuple into values. Expect tuple into values. I need to do that everywhere. What this code would look like with an 80 column limit. I mean, it's almost not even going past 80. I think 80 column limit is actually stupid. I think 100 is a better number. I mean, I don't know. I guess I could like extract things more to have not that much indentation. But yeah. Yeah, it's because the old monitors. Yeah, that's what I'm saying. Like, it doesn't matter much make sense anymore because these days the monitors are wider than they were 100 years ago, right? It's the same thing. It was written there already. I feel like into values also should be actually renamed into take values. But okay, maybe I'll do it later. I think we technically have an option for panicking because like, I mean, if we have a borrow checker eventually, then it should be fine. But right now I should be able to like have a reference to a tuple field, move the value out of there, and then like it will be panicking, right? Yeah. Nigel is teaching Velik a little bit of Rust. I thought Velik should know Rust at this point after watching the stream. All right, what is this? Binary comparison operator. If I have two tuples, then I implement the comparison for them because I'm doing the zipping of these. But I guess I should zip them. But first take them into values. So into values and then zip with the right hand side into values. You're just counting font colors. I see. Auto completion. Auto completion. I'm inspecting the locals. My value is actually just a place reference, right? So I have a place reference and then place type. And I can clone is the actual type. No, method mutate. So pattern match assign. So I have pattern matching and assigning the things to existing bindings. Instead of mutating the symbol, I just say get the symbol. Get the symbol will give me optional a place ref, right? Mutate. So this expect no not found. I think like this should be an unwrap here. So we get the place and then we assign a value there, right? So we should have a method assign on a place reference. Similarly, how I can like take value, clone the value out, we should also be able to assign a new value. This will be, can this fail? Can assigning fail? Like, I mean, if I store the mutability of a place also, right? So mutability is a property of a place, is that right? For now, not make it mutable. So self place state lock unwrap assign new value. So place state function assign mutable self new value match. I mean, not match. I just say that. So I just drop the previous value, right? If I'm doing this, so I just say self is occupied new value. Like that. This is not an iterator. Cast value to type, tuple into values. Tuple evaluate tuple value. This is a tuple values, but I should have the other thing like that. ASD, this is crazy. How is this crazy? Wait, hold on. Isn't this syntax literally from Ruby, which is the language that you like? Ruby closure. It's kind of the same. You also have the vertical bars here. That's not an OR operator. No, you have this. You have this in Ruby. You don't know your own language. Look at this. This is Ruby. What is this? This and prior arms are found to be value. I don't know what actually I'll be complaining about. Add local. Do I have add local? Yes. Value. So value is a place ref. This is when I'm using a namespace. Yes, because the namespace is just this. Yes. Oh, and this means that I can like actually reference the same value, which is actually nice. Previously, I was cloning the things when I was using the use stuff. Add local, insert a value. Wait, this is into the compiler scope? Is this only done there? Macro use. Down to gem. Hello, Pomo. I'm not sure if I actually am. I'm sorry. Not sure if I will participate in the gem. But yeah. Did you just post the thing about the down to gem? Later today? Alright. I don't know. I don't know. I will try, but like I wanted to do, I don't know. There's like just too many things that I'm doing. Game jamming is nice, of course, but I don't know. What should this be? Add local. A value. The value is a place ref. Namespace. That's a tuple. I am evaluating the namespace. I'm kind of cloning it already. All right. You know what? In that case, we just do. We just do into values here. I don't care about this for now. Tuple. Found place ref fields. Yeah, so field access also should give me the reference, the reference to the place. Yeah. So if this is some field reference, this is a reference to the reference. Yep. And then I just clone the reference. Place ref. So which means that I return value reference out of a field access. When I'm accessing a field of a tuple or of an object, return the reference like that. Is Linksider's Steam page up? Yeah, it is. But we will return. We will. We're also going to like publish the demo soon, which is like in a couple of days maybe. Steam page is there, yeah. Value and value shape. I need to do this dot into. Okay. If I do this, then fields is a tuple of place ref, because this is the stuff. Wait, what? Because I inspect all the locals, and I'm actually constructing the references there. Interesting. I think this is actually exactly how it's supposed to be. Tuple value fields. Can I do this? Can't initialize. Okay. This means that I'm going to reference the same stuff. Makes sense to me. You refactor your event of code, it'll leak the input strings because you want to use static references to them. That's probably good for performance if you leak stuff and you don't free it. That's one way to make your program faster. Just never free resources. You can also like allocate statically. You free them later. How do you free if you leak? You have some unsafe code. Static references are easier to work with. Out of memory panics make the problem finish running ultra fast. You do, yes. Do you do unsafe? So wait, hold on. So you leak them to get static references, and then you unleak them. Okay, interesting. Static references are easier to work with. You can just use a argster, for example. Then it's going to be like safe. That's basically like a static string too. But that is like cheap to copy. It's not as cheap as just the reference, I guess. But it's safe. Depending how much you want to be blazing fast versus being safe. What is this? So I have a pattern tuple. I have a pattern tuple. What is this? A pattern matching. So if I have I'm pattern matching against the tuple, right? So value is a tuple. I just do value into values here, then I think that's all I need. Next. Illustrate tuple context. Context is a tuple of unknowns. Because this is into, right? Yeah, so this should be tuple value. And then I convert that into the thing. I can also make like tuple value new. I can do that. Then I don't need to specify this, and this will be inferred. Tuple value. Public function new. Values. Tuple value. Self. And we just do values dot into. Default number type, tuple value new. How does that work at the end of the program where the static refs was free? Do you somehow guarantee that this static is no longer around? Yeah, like you need to wait. Is it undefined behavior in Rust if you have a reference to the freed memory? Or is it if you just have it? even if you don't read from it, right? It's also already undefined behavior. Like you cannot have a reference to like uninitialized memory. I know that. I don't know about the freed memory. Probably the same, I guess. Yeah. So you need to make sure that all the static references are also out. Yeah. I'm wondering if Miri actually is checking for those things. Is it? And the interpreter that I'm implementing here is basically the same as Miri. Do they implement it the same way in Miri? That's also one of the reasons my interpreter is super slow right now, like just like Miri, right? Do they have something like this where they have the place which is either uninitialized, occupied, or moved out? Probably. You like, then you drop string from raw parts, but isn't string from raw parts taking a pointer, not a reference, right? It's a pointer, and leak gives you. I mean, yeah. I mean, I understand what you're doing, but like having a pointer is fine, but like Raymarch was concerned, the just having a reference to the data that is freed or uninitialized is undefined behavior in Rust, even if you don't read the reference. Base state. Infer value shape. If I have a tuple, then value dot into. Mismatched types. I have a user-defined macro. Value shape tuple. Tuple dot into. Is this not going to be able to be inferred actually? Looks like it actually being. Is it because I only have one from implementation? I think that's why. OMG. What do you mean OMG? You're impressed with my code? Again? It's a static mute. It's not a static mute, it's a star mute, right? Add local. Value is a place reference. Why is this? Macro use, yeah, because I'm doing the use here. Namespace, I guess we do the same into values here, and that's it. Cast call. F is a place ref. F default number type context. Expect tuple unwrap into values. All right, look at this. All of the things, all of the warnings are done. Place error is more strict. Place error must be public in them. Okay, nothing is going to work yet though. Nothing is going to work. Let's just see what happens. What is going to happen? I shouldn't be able to even like drop into the REPL yet. So yeah, you see expression evaluated to the incorrect type. We expected the reference to type, but we got type. When I was evaluating self, add std_lib over there. I think like the expected was actually normal type, but we got a reference to type. Yeah, so here's what we need to do now. Now we need to like change the compilation. Nothing is going to work. Hi. I need to change the compilation to inject the new type of like instruction, which is the reading the value behind the reference, right? So we introduced the references, but I did not introduce an instruction like that. So I need to have like a read reference, right? So reference is an expression, and that's it, I think. What is this? Collect bindings. Read reference doesn't do any bindings. Show short expression, read reference. Data. Okay. So this is when I'm evaluating the reading of a reference. Let's see, expression, read, reference. I don't care about the data. So how do we do this? I say that reference is, first of all, you need to evaluate the reference itself. Right? The reference is going to give me a value. A value must become a reference, right? So I do something like expect ref. Expect inferred. Expect ref. Going to have a function expect ref is going to return me result place ref. Static mutable refs seems to be a whole topic. So I think for me, I will not have static mutable references. Because what's the difference between static mutable reference as a non-static mutable reference? Like the way I'm treating the language, even like what's the difference between like, I don't know, a function and a closure? I don't see any difference for myself. I don't have any like any like notion of static. Static is basically like the like static is basically like the global scope kind of, and that's it. That's the only thing, right? I mean, yeah, I guess, I don't know. No, 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 no. Where does the function store its capture? If it's no different from a closure. Isn't a closure the function plus capture thing? Yeah, my functions currently are closures. Yes. If I declare a function, it will like capture the environment. But the thing is, the thing that I'm capturing, so like I'm capturing things that exist at compile time. I don't like draw a strict line between compile time and evaluation time, but I guess I will be able to like um, to like inspect that later to like optimize it. But yeah, they have state. Like think about this function in Rust, right? Function fmt here, right? Like you see how in this function I am referring to, I don't know, I'm referring to the symbol OK here, right? So how does this work? In my language, this means that I'm actually capturing the value OK from the outside scope, right? But this value is like a compile time value. But it doesn't really like work much differently for me, if that makes sense. Kind of. Although I mean, no. This is like this is not really like a. I mean, in this case, the OK is like a function that is being captured, right? So yeah, I'm capturing the function OK, the constructor here. You are confused? You find the Rust const coloring of function a bit awkward. Yeah, so I will just have it based on effects, I guess. But I mean, coloring of functions is like is the same as like the effects. I'm just going to be able to like mix the colors easily because const is nothing special, I guess. You are confused, which doesn't mean much. Yeah, I don't know. I maybe said some confusing things right now. Never mind. But yeah. So like the way like I'm doing things, I'm not like drawing the line between the compilation, like compiler is basically the interpreter for me, right? So when I'm declaring a function, is the same as declaring, it's like working the same as the closure, and I'm just capturing the things that are available during compilation, which is like, and compilation is just interpretation of the source code, so it's just constructing a closure. I don't know. 25.4 edition will be released in 2 weeks. Oh, nice. Nice. I cannot think of any time where Kuvi did not say confusing things and the viewers were confused by that. You can also wrap all the graphics nonsense base better than the current languages. Maybe. But I mean, like the idea is like Zig, but better. Kind of. I just like imagine if Zig had also not only the comp time, but like a good type system. But that's the idea. For now, the implementation is far from like being there. Incompatible types. No method expect ref. Yeah, I was making the expect ref. Was I not? Over here somewhere. Oh, there you go. Expect ref. expect error. Value shape. Texture. Did you finish the card game? Not yet. You wouldn't believe how messy arrays on the GPU are. There are like 6 different kinds with the signs known at different stages. I should like... I don't know if I should be the one who's doing that. Maybe... I don't know. Like, to talk about the GPU stuff, I need to have tried it more deeper than I did, right? Because I only worked with OpenGL, with old school OpenGL. Expect ref. Maybe you should try the language once it's ready in 30 years and like do an abstraction. You hit so many roadblocks with Rust. Expect ref. Match self. If it is a ref, then I return this. Even otherwise, error. Expect error. Value. Expected reference. Cast Steam trailer when? Well, if we release the programming language on Steam, that would be the first programming language that was released on Steam. Is that right? I mean, we'll make a game where you like program in this language, right? Expected unit, yeah, over here. I need the reference. So the reference now is the place reference. And in order to read the reference, I just need to read the reference and take the value out, right? Right. What do you do for a living? Do you make a lot of money? No, not a lot. I'm doing programming for a living. I wasn't working for a long time though, so I was making zero money for like a couple of years. Not zero. I mean, I almost did no work. Started working recently, so there's going to be less streams now, but I wouldn't say it's a lot of money. I mean, it's so like relative. What is a lot? Like the fact that I could not work for a while means that... Does that mean that I was making a lot before that? Because I was living off my like savings? I make over 100,000 a year. No. But I'm also not from the US. I am from Russia, and it's kind of cheap here. I don't think there's a lot of people who are making 100,000 a year here. X is a compiler alignment chart. Java doc is a compiler. I mean, technically it's true. Microsoft Word is a compiler. A coin flip is a compiler. called PPP, purchasing power parity, when different amounts of money in different places have the same purchasing power. Yeah. Yeah. Is there like actual numbers to see, to compare? Like what would be the I mean, even if you like, if you're inside the U.S., if depending on where you live, it probably matters much, right? Like at least the rent um differs a lot. Match arms have incompatible types. Expected to result because take value should be unwrapped here. And by the way, taking value should actually be copy, right? So actually, now that I'm thinking about this, this should not be called take value. This should be called claim, right? Should I um did we have a different name for it? So that's the current idea of Rust. In Rust we have clone and we have copy, but sometimes we want to like to like copy, but not a super cheap operation. Like for RC and ARC, we want it to be like implicit. So that's what I'm implementing right now, an implicit thing, which is why it's like take. Whose blog is this? This is by Nico, who is like the creator of Rust, or like one of the lead developers of Rust. I'm not sure what his like role there actually is, but yeah, one of the main people behind Rust. There's a GitHub tracking issue for this thing already. If it's a tracking issue, doesn't mean that the RFC has already been merged. Hold on, Rust claim. RFC. Something different. That RFCs? Alright, let's look at the RFCs claim. Simplify lightweight clones, including all into closures and async blocks. No magic boxes. There's also a discussion about differentiating between @mute and some inner @mute, so that may not assign or std memory place. Claim syntax like use or claim instead of this. What is this? You just claim or use but limit. This is the only reference to claiming that I see in the that I found in the RFCs. Like this is something a little bit different. But I mean, no, like, I mean, lightweight clones is literally the thing, right? Provide a feature to simplify performing lightweight clones, such as arcRC, which is like this idea of like claiming, right? Although this part is introduce noise every time. This rendered. Motivation is this. Dot use. As a separate use of the object to some function. Dot use. When working with objects that supports lightweight cloning, such as RC or ARC, you can get an additional clone of the object by invoking don't use. What? I don't think I like that. I mean, so like it's just like it's like different than just writing dot clone. You just now do dot use. It supports chaining. No way. You hate the dot use name? Like if it is the dot use, why is it not just another method? Because they want it to be like to be done automatically on the closures. That's like the only reasoning that I am seeing here, right? Because if you want to like move into closures the like cloned arcs, you cannot just move, you need to like clone them, and that would like do that automatically. That's why it is a keyword and not just a method. So they other names proposed for this mechanism include claim, yeah. I feel like use is already used for other things. I don't like the name. But yeah, naming is difficult for sure. But yeah, the just because of that, I should have the same. So like if I have a copy type, then or like something that can be like claimed, used, whatever, then I don't take the value out of the place, right? I copy it instead. But let's for now just do this. Should it depend like on a different expression then? What if I had a copy type? Is there any use for me to like provide instructions to move out of a copy type? I don't think so, right? I mean, is that useful? No. Use is used for a lot of things, like lifetimes and signature. Lifetimes in signatures? Use? Oh, yeah, that's right. Also, for is used in like for. Wait, use in signatures. That's like the new stuff, right? Also, Rust use lifetime. Like there is like this syntax, right? Use with brackets. Not the for-a. Lifetime capture rules. Use in Rust 2024. So like it's not there yet. That's what's going to be released in 2 weeks, right? All right, I want to finish if I can. I'm not sure if I can finish because I don't have a lot of time today. Need to end the stream soon. Non-exhaustive. Initialize expression. So if I have expression which says read the reference, then this is initializing the type inference. So the datum is expression datum, which includes the type inference stuff, which should be reference, place. What's a reference here? It's a box expression. So read reference must be a reference for sure, right? Type, so like inner type is a new not inferred type. Then we say that reference type, so reference data type makes same as the type. So yeah, so the type of the reference expression should be the reference of inner to the inner type, right? Like that. And then the so and then the result of me reading the reference is the inner type. There you go. Number reference is mutable. Whatever. I wonder if I can make a Turing complete language just using Rust lifetimes. You should join them exclusively and a name chooser. Mutably as name chooser. Reference data type. Okay, everything is compiled, but nothing is going to work still, of course, because I'm not generating the read reference expressions yet. And this is what should happen automatically. And the question is, how does this work? How does it work in Rust, actually? So, like, we should automatically insert the instructions to read a reference when? How does that work? Without votes. I think we can see something here. Pin places. No? Ownership. References are like jumps. Maybe not in this one. How does that work? So basically, let's see. When we say, like, you know, let x be 0, and then we say let y be x, right? What actually happens here is this should be compiled as like read the x, where x itself is not the value of 0, but just the place in which the 0 currently lives, right? So we are trying to read this, and this should be like inserted automatically. But at the same time, if I say let z equals to reference to x, because I'm just taking the reference to the place and don't like really read the value yet, this means that reading should not be inserted there automatically, right? So it depends on the actual instruction, right? So when I'm compiling, like let's say that I'm compiling let like pattern be value, then I need to make sure that the value is a value. So I need to get rid of all the places there, right? That's right. But that means that during the compilation, I need to know if the expression results basically in a place or in a value, in an L value or in an R value, right? So whenever I'm compiling an expression, right now I have the data associated with expressions, which has its type information, right? But in addition to the type information, I should know if it's like a place expression, right? I mean, I kind of know that from the type inference, but in order to initialize the stuff further, I need to know that immediately, right? Because place, so like type inference can work backwards, but can like that stuff work backwards? I don't know. So I'm thinking that expression data should have the type and like is this a place expression should also be like stored there, right? So let's see, these are all the expressions that we have. If I read a reference, then this thing should be not a place expression, right? Anymore, because I have read the value that is inside the place already, right? If I have an expression and, for example, then the result of that also is not a place, right? This place is false. If I have an or, this place false. If I have an assignment stuff, this place false. If I have a list expression, this place is false. So for which, so some expressions are just place expressions, right? Which is mostly just getting the place by its name, and also like accessing fields also can be a place expression, right? For example, current context could be a place. I feel like that can be a place. So I can like get a reference to the context and not actually clone it. Unit. False. Function type. False casting operator. Since this is casting, I think it's false. If I have a match, pattern matching. So that's also like the difference between Rust and C++, right? Because in Rust, like, one thing that you can do in C++ and you cannot do in Rust, you can like call function get reference, and then you say like equals x. That's something that you can do in C++, but you cannot do in Rust, right? Because yeah. Should I be able to do that? What do you guys think about this? The fact that in Rust you can only return like references. You need to dereference it, right? Is that an upside of Rust or a downside of Rust? Short stream. I mean, I'm gonna end in 20 minutes. This particular case is a downside. So like one of the things that I mean, it can be seen as both an upside and as a downside. For example, let's take about like there is a function memory swap, right? You need to pass it a mutable reference to A and a mutable reference to B. While in C++, you would be able to just say swap A and B. This makes it less like explicit, the fact that you are not passing it by value but by reference. But it's like kind of the same thing as here. Should I be able to return? So basically in Rust, reference is a pointer. This anonymously seen as a problem. So people in C++ don't like this, and they want this to be explicit, right? Okay. I think it's like I think it's easier to implement it the Rust way for me, but I'm just thinking, is there like a good thing about this? So like there's two separate things, right? Passing arguments into a function and being automatically referenced, and also like trying to return something from a function that is not actually a pointer, but like a proper reference or a place in terms of in like Rust terms, and right? The fact that someone can non-breaking change still an at mute for you. There is a problem like that in Rust too, because in Rust you can have methods, and if you have like function a.foo, and this is like this can mean anything. This can mean taken by value, by reference, or by mutable reference. So like, does this actually help anything? The fact that this is explicit, if you still have like the same issues with methods, or should we not have methods because of that? So I'm thinking right now of doing it the Rust way, but like I'm open to thinking about it more. So this means that, for example, a match expression will not be a like, for example, should I be able to write let x be reference to match like something y, right? So should this result into reference to y, or should it copy the value of y and then take a reference to the temporary object? That's the question, right? I guess the way it's working now that I'm thinking about it, the way it's in Rust, the fact that this is copying it is more obvious. Have methods the way Lua has them by owning a reference to the function. And there are also implication on pinning. Yeah. Okay, is place full. So mesh expression is not a place expression. Is expression is not a place expression. New type is not a place expression. Basically, like, almost none of my expressions are place. So let's just copy that. Variant is not. Use expression is not. Tuple expression is not. So, but field access should be a place expression, right? So field access is giving me a place where the field lives. AST expression. False. False. Function. False. Template false. Scope false. If expression false. Then false. Constant. What about a constant? I mean, that's a constant. False. Yeah. Number. Number is not a place. Native. Not. Let is not. Not. So basically, when I call a function, it will never return a place, and I will need to dereference it manually, like in Rust. Is what this means. Unless I like figure this out somehow else with like the type inference. Is place true. So true is only for the current context and for the field access. I feel like that's not the only one. I feel like I missed something. Binding? Yeah, this one, binding. Because when I'm getting the binding, it means that I'm getting a place of it. Yeah, there you go. And it means that the type of this, right, is so the type of a binding expression is not the type of the value inside the place. It's a reference to that value. So type shape reference to this, right? Scope. Field accesses are also smart in Rust. I mean, that's the borrow checker. That's going to come later. Right now, I'm just going to have the runtime borrow checking. Okay, so this means that... What? What does this mean? Cast executor. Expected type reference to not inferred, but got type. In function type, standard library 115. What I need is to... So for all the inner expressions, if I know that they are place expressions, like for example, right? For example, let's say that I have an expression a and b, right? A and b. We know that a might be potentially a place expression and b might be a place expression. I need to automatically read the value of the place in that case, right? So now everywhere I should say that left hand side is left hand side like I should have the something, you know, like read place left hand side, right? And the right hand side is the same. And then I would have function read place. That should return me an expression, right? And basically it will say that if expression data, if it's a place expression, then I should automatically read this. Otherwise, I just return the expression as is. And here I say read reference, where reference is the original one. And data. Let's see. So now the is place is false. Type is is the same. I feel like I just need the spend here, and then I do call the initialization. And then it's async. Why is it async? Because of things. Okay. Fine, then I will just do that here. Just the same stuff, right? Because the expression is a place expression. The expression is that. This place is going to be false, and the type of this is the inner type. Question mark. In this case, can be unwrapped. Maybe. So just do this, right? And then I will need to like box it again. Sure. Okay, and now I need to do that everywhere. Okay, can I run this stuff What can I have? Like I can try fixing just some things, not all of them. Can I run without the standard library? I think I could. Course main. Clear REPL, no standard library. There we go. Is no standard library also giving me no syntax? I'm not sure. Just run REPL, no stdlib. Because then I at least drop into the REPL, right? So if I say A, it will say while compiling A is not found. If I say A is equal to 1, A is native int 32. Result unwrap. Okay, there you go. We moved out something. Okay, shit. Yeah, this is going to take longer than today's stream. I feel like I'm very close, but I need to end the stream, so we're going to... Maybe I will finish it off stream. Or maybe I will stream more of Kast some other day. Raid Venner Sigma, I was looking at who to raid, yeah. Average unproductive stream. That's just how we like it. Alright. One thing. Yes, what thing? You have 10 seconds. 9. Did you know there is a lifetime checker for Zig written in Elixir? But how can you check the lifetimes? Like where's the lifetime information coming from? Isn't it supposed to like? Is it something like JSDoc kind of thing where you specify the lifetimes in comments? AST analysis, you can only get so far with it. I mean, it can get you pretty far, I guess. But not as far as the Rust lifetimes, I think. Anyway, thank you guys for watching. See you next time. Bye.